Welcome back, everyone. This is a bit of a follow-up. Been some great messages. Dirk sent me a message or a reply on Google Plus, and it's kind of after the fact. What he said makes perfect sense. These shafts, if you can see here, go straight into the coupling nut, and the coupling nut is very stiffly pressed into this plastic. And when this is printing, you guys have never seen this, but when this is printing, there's almost 5 millimeters of run out in an orbital pattern on these. And this was the straightest rod I could find in the hardware supply store, and I cut it in half, right? But still, there's almost 5 millimeters of run out up here, and that's passing through a coupling nut. Down here, there's hardly any, but the vinyl that attaches that to the motor is a pretty stiff and seems to have self-centered, but doesn't mean that it's, truly centered. Dirk was saying that it's a Z-axis wobble because of these. Now, in my early videos, for those of you that have seen the earlier design videos, I do have bronze bushings that fit over this very, very well. So I can capture these. I could print a part that would grab onto here and go out and capture here, or I could print another one of these big enough to grab the bronze bushing and mount it to the wood in the back, and that would capture the tops. That would be one way. A real simple way, you go back to one of my very first ideas, which is to put the coupling nut into a part like this that would be underneath here, and then it would have, I can't remember which way I had this done, it would be under there, and it would be there for the lifting force to push up on this plastic, and then there'd be a little part on the top of it that would come up and grab the plastic on the top, so when the nut went down, it would pull this down in case there's a slight bit of friction in here. Not much, but there is. But that way the nut, this would be free to slide around on the plastic. Like, it would move in the X and Y axis like this, but constrain the Z axis, because we don't want the Z movement affecting, or the Z axis, depending on what country you're in, we don't want Z axis affecting the movement. Now this seems pretty stiff here, and if I'm pulling on this, you can't really see too much. But if I look, there's at least 2 millimeters of flex. Now that might be because of the aluminum, it might be because of the fit here, but there's about 2 millimeters of flex that isn't related to this back plane, which means this here out in the middle has got about 2 millimeters of movement. And under the higher speeds and the higher up it got, if you look on this, the weird markings, of course they're fine near the bottom, they're pretty good. Then you get up here, as you get higher up, there may also be a slight bend in these lead screws, so that could very easily be causing a millimeter or so of plus minus movement in both axes. Actually, you could get a little bit of left and right and back and forth. So although the bed is probably moving fine and the head is probably moving fine, the actual gantry that X is on might be gyrating. So I did a few other tweaks, and I printed out another one of my wife's favorite kind of rings here. It's like a kind of like a knuckle duster, and the edge on that is really, really good. Okay, but that was done slow. But if you notice, it's not very high. It's only 7 millimeters high, and 7 millimeters high is still below the threshold where most of that crappy that happens. And if I look at the face side and all around it, it's smooth on all edges, except a little bit there. But its orientation for printing was that. And it did, yes, it stuck to the tape and I had to rip it up. But the thing is, I printed much slower. This was perimeters and walls and stuff for 15 millimeters a second, and infill was limited to 30 millimeters per second, not 60. So there was a lot less inertia on the head and whatnot moving. But I think the most part of this is, as Dirk and a few others had said, is these lead screws. Now there is a simple test, and I might do it later tonight. Drop the speed, let this take an hour, a couple hours to print, put this on a slow setting, and if the marks are still there at about close to the same magnitude, then it is definitely these cheapo lead screws. I mean, it's $1. These things are like $1 for, it's one rod and then you cut it in half. The nuts are like $1.50, so you can't really blame them. They were never intended for this use. But I'm pretty sure I could clean up any lateral forces they're causing by making this sit on something like a washer, so that this is free to move around this way underneath. The nut will press fit into this, probably even glue it, and then there'll be a little arm that comes up from that and just rests on the top, or probably screws into this, so that if the nut pulls down, it'll be able to pull this down. Because these bushings works really good, but there's a tiny bit of I don't know what you'd say, like a starting friction you got to get past, and that axis doesn't move very much. So, and it's mostly up, so I'm not worried about the down, as long as I can get it nice and tight. And there's no, it's hard to display, but there's no backlash when you use a coupling nut. It's so long, there's like zero backlash, and you fill them with graphite powder. Sorry, graphite is what I used at that. And then your backlash drops even more. But anyhow, so that's the plan. Really slow print before I attempt the fix. And then I'm going to not use this piece because it doesn't work with these designs. I'm going to make a slightly different version of this. Drop those nuts down to get into the plastic below. And then use a washer type separator. And then there'll be a little arm that comes up and just not grabs, but sits over the top, so if the nut needs to pull this down, it can pull it down. And that's my plans. So as always, thanks for those with suggestions and help and interest and whatnot. If you have any comments or questions or help or useful tips or hints, go ahead and put them down below. I do usually get to them. Sometimes I'm out and about and can't get to them right away, but I do get to them. And don't forget to like and subscribe if you like these crazy projects, and especially those that like to help out. Thanks, and I'll catch you in the next video. Okay, really short update. It's just a test print star that is going to be the bottom of a pretty classic ring for me to print here, one of my old ring designs. But the update is really about this. It's a decoupling thingamajig. It's hard for you guys to see, but it's a reprint of this part down there to capture the nut, with a washer between that and the top part. In the back of this, there's a tongue that sticks out and goes into one of the holes in the blue part, and that stops it from spinning. Oh, we just saw a Z-axis movement. And the zip tie on the outside edge has just been added for good measure. I don't know if it's actually going to do anything or what, but anyhow, it printed. I printed that and a mirrored one on the other side not too long ago on this. But I've also found what might be part of another problem. One of the wires going to the step motor in my homemade wire might have a bad connection, or it might be, again, some oil on the ramps board where it connects in. So I'm going to have to pull that off and do an alcohol clean. But once this print is done, I'm going to inspect it to see if these things made any mechanical difference. But we'll see, and I'll get back to you. As always, thanks for watching.